All right, problem number 12. Let's go ahead. This is kind of a repeat of one of the problems we did before. We want to get the distance traveled between 1 and 2 seconds, but this is going to be a definite integral from 1 to 2 v of t dt. This is almost a calculus problem, like from AP Calculus, so let's just go ahead and integrate it out. This is going to be 4t squared over 4 plus 2t squared over 2, integrated from 1 to 2. So this will be t to the 4th plus t squared from 1 to 2. So that's going to be 16 plus 4, which is 20, minus 2, which ends up being 18 meters. Now here, we want the order of magnitude. That's the power of 10 that the force is equal, that the force has after it when you multiply it out. So here's what I mean. So let's get the gravitational force. It's going to be g. We got two masses that are the same, so I'm going to call this m squared over r squared. So this is going to be 6.67 times 10 to the negative 11th times 9 over r squared is 36, so this ends up being 1 over 4. So our force is on the order of 10 to the negative 11th. And let's go ahead and take a look at question number 14. So we want the ratio of the escape speed to the orbital speed. The orbital speed is found using centripetal force. G mm over r squared is mv squared over r. This is orbital speed. So let's cancel some of this, work that out. And so v orbital is going to be g m over r all under square root. Now for the escape speed, we talked about the fact that you need the right amount of energy to escape. So the kinetic energy is equal to the potential energy at the surface of the planet trying to escape from. These little m's cancel, and so what you end up getting for v escape is 2gm over r all under a square root. So the ratio is the square root of 2 times this stuff over this stuff. So we get A as our answer. That's number 14 here. This is an interesting question. So let's actually look at the force. So if you have one spring, F is kx. If we have two springs, we have 2F equal to 2kx essentially. So basically what's happening is that we have an essential doubling of the spring constant. So in other words, we're getting a new force that's twice as big, and it's like we have one spring that has twice the k. So the old period was t equals 2 pi square root of m over k. For our new spring, we've got 2 pi m over an effectively doubled k. So what that means is that the new to old ratio is b. All right. Now we want to know possible energy functions. Let's be clear. So it's either 1/2 kx, so 1/2 kx squared, right? And we know x is some kind of a sine function. So we need a sine squared in our answer. So let's be clear. This will not work. This will not work. This will not work. And let's be clear on one other thing. We need the 1/2 factor out front, so that rules this out. So we're left with choice A. All right, so that's the third page of the exam, and we'll continue in the next one.